And there we go. All right, so thanks again, all of you, for coming. Today, we'll be hearing Brad Gingell speaking. He's from Strayos. As COO of Strayos, Brad leads the development of AI solutions that combine visual and operational data sources to solve tangible use cases for mine operators. He spent the first phase of his career optimizing drill and blast activities for over 100 sites as a mining engineer with the world's leading explosives providers. He then expanded the scope of his support to encompass all commercial and operational functions by moving into management consulting with the top-tier firm Boston Consulting Group. Brad holds a Bachelor's of Engineering in Mining Engineering from UNSW and an MBA in Finance and Entrepreneurship from Carnegie Mellon University. Thank you very much for speaking to us today, Brad. I'm going to hand it off to you.
Amazing. Can you guys hear me? Nice. Thanks for the intro, Joe. And yeah, great to be here, guys. I was actually just telling Joe before this that this is when he showed me the room and spun the computer around. This is not the first time that I've presented in this room, but like 6 years ago, I think it was now, I did one of these when I was working for Buckley Powder Company, living in Denver, in this very room. So good to be back, I guess. So as I guess a quick background on me, as Joe mentioned, I'm a mining engineer by background. I basically started out, worked on a few sites and specialized pretty quickly in drilling and blasting, working with Orica all around Australia, and then came over to Denver in the US and was working with Buckley Powder Company for a while there. So I know Denver relatively well. I was there for about 2 years. Then moved over to Pittsburgh, did the MBA thing, and came back to Australian management consulting. So then, yeah, as was mentioned, kind of focusing on those higher level business related issues, getting that broader perspective. So yeah, as Joe mentioned, now come back to Strayos, where we build AI solutions for the mining industry. And I can give you a bit more detail later into what that really means. That basically we have a software platform that people can use to kind of do basically 3D surveys, photo surveys using drone models, use AI tools to extract valuable insights from those models, design drilling and blasting activities, measure blast results, and then link that all together into a kind of optimization, continuous improvement model. Cool. So getting started on the topic for today, here we're going to be talking about the key to digitizing mining operations. So this is going to be quite broad. If I jump to the agenda, it lets me, there we go. So keen to talk originally at a kind of higher level across all of mining. How are we going? What's the opportunity? What's kind of coming in terms of digitization? And then how in general we need to be thinking in the mining industry in order to succeed, because there will be winners and losers. And we all see this in every other industry, that those that don't adapt fall away, and those that do are the winners in the next generation. So what do we need to do at a broad level to succeed? And then finally, I'll go into drilling and blasting as a deep dive, as this is my area of most expertise, to kind of bring it to life in a bit more of a tangible way. So jumping in, I'll start with our current state of digitization. So I'll go back and take us back to 2015. There's a pretty famous piece of McKinsey research that was done then about digitization, digital transformation in the mining industry, that found that there's about $370 billion worth of opportunity there, which is massive. It's about I think they said it's 17% of the total cost base of mining in 2025 is about the size of that opportunity. So where you see something that's so big like this, you know that that's where that's what people are going to be aiming for, and that's what people are going to be taking seriously. So I guess the reason for showing this is to say that bringing in digital technologies is a big opportunity, and the so what is it's not something that's going to be going away, or always as a third priority at the back of mind. It's something that in the boardrooms of the major mining companies of the world, it's being taken very seriously, and that has to flow down to site as well, to engineers, to operators in the field. The interesting thing to also to kind of pull out of this, going a level deeper, these bullet points they talk about where the value is coming from. So deeper understanding of the resource base, optimization of material and equipment flow, increase in mechanization through automation and monitoring of real-time performance. So the first one, I guess the first one and the last one are really about gaining more data. One on what are our inputs, what are we working with, and then the last one being on what are the results that we're getting. And then the second one is basically tying those two things together to say what's the best way we should be doing things, how do we make better decisions. And then the third one there, that automation, is obviously once you've got a good way to make those decisions, being able to let machines start to do that operationally in the field as well. So those things all do tie together quite nicely, and you'll see those themes come up later as well as we go through the presentation. So huge opportunity. And I think really the foundation for why this is, why they wrote this at that time, and the basis for this opportunity is that the technology is now there. We're not waiting for any of the components anymore. There's data capture and sensing solutions already in existence for capturing all of the types of data that we need to kind of take that opportunity. We have so things like, I guess, drones for the 3D modeling side of things, LiDAR sensors on vehicles. We have sensors for processing plant equipment to measure everything from flow rates, belt weights, operating parameters, everything like this. We have all of those. We have that data. We have now the tools to manage that data and analyze it too. So we've got cloud computing infrastructure is pretty easy for anyone to set up nowadays. You can get all of these different sources of data from all these different sensors, and you can put them in one place and tie them together. We have now the AI and the statistical techniques pretty well established in not just academia, but in other industries as well, for putting this to use to make better business decisions out of it. So that's all proven out. And then in terms of actually implementing that in the third category, we are seeing already OEMs with production-ready versions of autonomous drills, autonomous trucks, autonomous bogging. You've even got there's a company now in Australia doing autonomous seed planting for revegetation. Dendra is doing that. So there's people who've already proved out that kind of, robotics control system side of things as well. So all these things are there. The challenge is just putting them together. That's the thing that people are struggling with. And they really are struggling. So this that research from McKinsey done in 2015 was saying that there's a lot of opportunity. This research is from this year from BCG, showing that that mining is still behind, despite having all that big opportunity. Mining is quite a fair way behind other comparable industries, 30 to 40% less digitally mature, which I'm sure, as all of us have probably worked in some way in the industry, we kind of feel from time to time. And that the interesting thing is that they found that the reason for this was maybe not as much on the strategy side. So a lot of mining companies have these strategies. They know these technologies exist. They know they should put them together. But the issue is executing on them, is kind of bringing them to life and actually getting value out of them. So I think that for digitization, the thing that we should be wondering about is how to better execute on digital transformation. So next, we should be trying to answer this question, I guess. So let's look at how mines can succeed. So I've kind of broken this down to 3 key pillars. There are 3 things that you just absolutely have to get right in order to deliver on digitization in mining. So firstly, and kind of at the very beginning, you need to get the commercial structure right. So I know as an engineer myself, and a lot of people on this call, probably engineers, technical side of people, don't like to put commercial first. I was definitely flipping this back and forth when I was making this slide, but really what it does is it needs to be first. You need to have the right incentives for people lined up. You need to have the right systems set up in order to select the right projects to begin with, for anything else to work. So that's why this is really at the start of everything. So even as engineers, we need to be conscious of this, and we need to be ensuring that we're if we don't feel like these systems are set up properly, that we're pushing to make them work better, so that we're focusing on value when we deliver projects. So really what this is about is establishing business processes so that we can figure out what to do. We know exactly what to do. The next pillar is about actually designing it and doing it. So working out, well, now that we've decided that these are the right things to pursue, whether it's we want to do this autonomous truck trial here, or we want to do a more custom measure while drilling, like smart drill implementation over here, whatever the digitization initiative is that we've decided from the commercial pillar, we now have to go, okay, where are we going to get all of the bits of technology from to do it, and how are we going to put them together? So that's building an integrated system. One of the key things we've got to get right there is that balance between, do we make this thing completely from scratch, custom, bespoke, that only works in our current mine, in our current set of conditions, or do we try and make something more flexible or use something off the shelf? So finding that balance is what I've seen is the biggest challenge in this pillar. And then finally, the last pillar, which is something that everyone talks about, but still is often the reason why projects fall down, is the cultural pillar. So making sure that this sticks, making sure that people actually adopt it, they're engaged with it, and that it keeps getting used over time. So it's about ensuring that people have the capability and the willingness to use it, not just one or the other. And I think going back to that BCG research in terms of execution, I think this was one of the main things that they found was lacking, that a lot of digital initiatives were falling down in the field because they weren't designed with the field in mind. So jumping to the next slide. So we'll go into a bit deeper detail on each pillar now. So firstly, on the commercial side, we talked about that it's setting up the right incentives and the right systems to prioritize things, figure out what we should actually be doing, which initiatives should be prioritized. So I guess, what are the issues with the way that things currently work today? Well, so I guess this is not a bad thing, but like mines always nowadays have fairly solid BI systems, business improvement systems in place to prioritize different projects, different initiatives, and there's a heavy focus on ROI. So if you go out as you start working in mines, you'll anything that you try and do, people will always ask you for a business case that has ROI. So it's something that you've got to get good at doing, at justifying. But the issue with this approach, if that was all that the system is that I mean, you could probably think of 100 examples where ROI is very difficult to estimate, and you'll come up against this a lot when you're out working at a mine. You'll find that this thing hasn't been done before, especially not in your exact circumstances, conditions, for your particular rock type. So for example, estimating, to use an example we're going to use later, how much improving fragmentation is going to increase your crusher throughput or something like that is going to be tricky to kind of benchmark, to estimate from the beginning. The next thing is that large-scale transformation is going to require a bunch of enablers that don't actually have any ROI if you just look at them one by one. So if you were trying to move to, say, this fully autonomous world, you would need to have some kind of underlying data system that tracks where everything is, and is constantly modeling in that digital twin form your entire site. And when you look at something like that, it's hard to say exactly how that will create value without any of the other applications built on top of it. So just knowing where everything is, you can kind of make some estimates of maybe a few people's time saved, but that's it's hardly enough to justify the massive cost of implementing something like that. But then that's something that is critical to have to then enable those next set of applications and technologies which do deliver a whole lot of value. So that's an issue as well, with just having everything rely on its ROI estimation. So the way to overcome this is to have the kind of a longer term view, essentially. Focus on large, long-term projects, look at the big picture and say, where do we want to be? If it is something like that longer term, if we say our goal is to fully automate, haulage in this mine, you're going to have to start with that longer term, larger goal in mind, and then work backwards to find what those enabler technologies are, estimate the value of that larger long-term goal, even if it's tough to do so, knowing that it's something that's going to be critical for for success moving forwards. So for success kind of in the future to remain competitive. So that's the way to kind of overcome these short-term issues with BI processes. So building a roadmap, essentially, working backwards. The other thing that's important is to make sure that you're considering the entire value chain when estimating value. So we shouldn't be just prioritizing things based on an estimate of the value that it can create at a certain point in time, a certain point along the value chain. So the issues are that if you, for example, say that you increase the capacity, increase the amount of dirt moved by, say, a piece of equipment, and say that's worth X amount of dollars. The problem is that then you'll get to the, when you look at the impact on the total output of the mine, you might find there's actually none at all, because even though this piece of equipment, moved more dirt, there's a bottleneck somewhere else. So you've got to have a value chain model in place for measuring impact. And the upside of this is that what it lets you do is consider benefits as well at other stages of the value chain. So that's often somewhere that you need to look. So especially in the drill and blast world, to justify projects, you have to look at what the benefits are going to be downstream. And then the final thing that I put here is not to be distracted, basically, by lots of shiny objects. So you only have a certain amount of focus. Don't let it be diluted. Pursuing everything, you've got to be ruthless and be laser sharp focused on where the value is. So moving on to the technical side of things, mines have to focus, instead of creating a bunch of different technical initiatives, have to focus on creating a tech ecosystem across site. So the issue with how things are done today is that generally the approach is that when we want to develop things, we do it in-house. We make things customized to our operations always. Everything's from scratch. It happens quite slowly. And it's also, each kind of component of that is designed just to work in isolation rather than with integration in mind, which means you might solve the problem. You might get a great solution for the problem today that you're having. You might develop one really good model that works right now. But then as soon as something else changes in the way that you operate, other software changes, you have new rock conditions, new suppliers, vendors, the equipment changes. Suddenly, whatever you built is no longer really useful anymore. So that's kind of the issue with building the way things are built right now. The other issue is that building things at all is just generally quite slow because of skills shortages. We don't have too many AI engineers, data scientists, software engineers working on mine sites. So the solutions, we need to be trying to test quick to deploy versions of everything before building custom things. So we don't want to jump in straight into building the most advanced thing from scratch first. We need to find off-the-shelf versions, quick MVPs that we can roll out to test whether firstly just the value is actually there, and to test the feasibility of the total system before starting to add on to that. So often that means, going outside, going outsourced at the beginning before building anything custom. The next thing that we have to look at is building in a modular way. So trying to have this data lake underlying everything, so everything connects to the same single source of truth for data, but having all of the different components be kind of plug and play on top of that. So having, for example, in the example we use in the autonomous haulage situation before, having one source of truth for just geospatial information, where everything is at any one point in time, and one source of truth for what the model, the most up-to-date model of the pit is. Having that be all in one place, and then your other things like maybe your haul route optimization algorithms, or your communication systems, sending information to and from trucks, is all should be modular and sit on top of that, so that you can, if you need to, you can, sub out that algorithm with a new one quite quickly, or sub out that type of truck with a different type of truck relatively easily. If everything's just built from scratch all together, then you're kind of bound to that forever, and you'll get into the situation that a lot of sites are in, where you have something that works very well for right now, and then in 30 years time you still have the same thing, even though it's quite outdated because it wasn't built in a modular way. And then the final point here is the build versus buy versus borrow decision has to be made very intentionally for every initiative. So building it in-house versus buying it, getting someone else to basically build it for you, or completely like purchasing another company to acquire that functionality, versus borrowing it, which is just signing up to use the software. That decision needs to be made not just on cost, and not just on this is part of our strategy to have this capability, but based on this the implementation and the execution considerations, like how quickly can we actually get this done? How can we test this with people in the field early on? These are kind of things that overall the industry needs to adopt, to shift from a more default option being buy mindset to default option being borrow mindset, which is the rest of other industries, the kind of more digitally mature industries, have adopted. And finally, I'll talk about the cultural pillar. So here I'm going to go into how this technology ends up creating value. So firstly, it needs to be embedded into day-to-day processes. When you go out to mines, you'll see a lot of projects that are being done as kind of the theoretical proof of concepts. There's a lot of research and development, and it's great that it's being done, but you need to start with the field in mind. As we talked about earlier, that's one of the main reasons why a lot of these digitization initiatives fall over, is that people aren't developing them with people in the field. There's a big difference between developing for the field and with the field, because at the end of the day, it has to be used. It has to work with existing workflows. So I guess an example of that, to bring it to life, is in drilling and blasting. You don't want to be, you can say it's all well and good to do optimization, but if you're adding an extra step to someone's job, that they have to go and run a model, and they have to build a report out of the output of that model, and then they have to go and do some calculations to work out how that actually how that can be implemented into the next blast design, then you've introduced a whole lot of new steps, which are less likely to be it's just less likely to be adopted by end users, because as soon as there's something that gets spit out of the model that doesn't seem right in the context of their blast design software, for example, they'll just stop using it. So we've got to take a human-centered design approach, essentially, and look at what the actual needs are of these people who are actually the users of these systems. The other thing is bringing people along the journey. So involving people from the field in the actual development and not just the testing and the proof of concept is a better way to get buy-in, essentially. You need people to be behind it. You need people to feel like they own these digital initiatives. And people are generally really excited to be part of this. There's I think, a too common kind of an attitude that, a misconception rather, that people in the mining industry don't want to be part of change and making things better. People are generally excited by it, but I think that the hesitancy towards it stems from the fact that often change is forced upon people, and that's something that they don't like. People do like being part of it and building it alongside each other. So the final thing on the solutions point I have here is this agile implementation. So it's including people from the field in this development process, having these teams made up of both developers and people in the field, and having them empowered to make decisions, make design improvements, as well as just providing the feedback. This also helps you get something built that creates value very quickly, and then can be iterated on in order to scale it up to that final version of your solution. So those pillars that we went through there, I think are the main things that we need to get right. I understand that was somewhat of a kind of theoretical view. I tried to throw in a few examples. So that's why I wanted to now kind of bring it to life a bit more with a deep dive into how this could look for drilling and blasting. So applying this kind of thinking in the drill and blast space, let's just all pretend that we are engineers, or even just business improvement people on a mine site, and we have to work out how we're going to what digitization initiative we're going to launch in drilling and blasting, and how we're going to do that. So the ways to think about it are looking at that commercial pillar, like what are the largest value pools affected by drilling and blasting, and which initiatives actually touch those value pools, can impact them. So so we'll come to an example of that after this. And then also which initiatives are feasible for our sites. So what actually makes sense in the context of what we do. Like, we're not going to be doing a cast optimization project at a hard rock site. We're not going to be doing as much like dilution, ore zone control at a coal site. So what makes sense for us, and what can we actually do given our constraints as well? Obviously, open cut and underground have very different technical constraints. On the technical side, we're going to be looking at, so then once we've decided what we want to do, what modules of technology are required to implement this. So break down the entire system into various modules, and for each one, look at what's out there on the market, what do we need to build, where are the gaps. Then look at how quickly can we actually get an MVP version, a minimum viable product version of this going, in order to prove value and prove feasibility. So then coming down to the cultural side, we'll look at what processes does this impact, like who are the people involved. This is where you're going to say, well, maybe it's something about is it the blasting engineer that needs to be doing something different day to day in order for this to work? Is it the IT team that need to be doing something different day to day for this to continue to run? Like, who are the people and what are they currently doing today? And how can we get those people involved in the design of this product? So as an example, look at fragmentation optimization. So fragmentation optimization, to me, happy to be challenged on any of this, but I think impacts the largest value pools for drilling and blasting. Value pool just being the number that the total number that you can address. So optimizing fragmentation essentially allows you to address the entire site revenue for a lot of mines, because crushing and grinding is often the bottleneck, being the largest piece of equipment that's hardest to kind of change the capacity of. And so therefore it's often the bottleneck. Increase the capacity of the bottleneck in a system, and you'll increase the total throughput of the system. If you can increase the total throughput, you increase the total revenue. So if you're optimizing fragmentation, you can essentially address the entire site revenue. You can say, we're going to increase site revenue by X%. Then you have a cost value pool as well. So on the crushing and grinding side, say that you're going to keep the same throughput, the total system throughput, and just reduce, the amount of consumables, the amount of energy that's used in the process. You've got basically crushing and grinding costs, the entire crushing and grinding costs as your value pool, and that's massive. That can be a quarter to half of the total site cost, just in electricity and in consumables for the mill. So optimizing fragmentation, you can say that impacts the largest value pools. So that's a good one to prioritize. You might then go and look out at, okay, what are the different modules that are required for fragmentation optimization? What exists today? What doesn't exist today? And you find that actually to do this fragmentation optimization, all of the components, all the modules really already exist on the market in a form that you can go and borrow them, rent them, rather than having to build anything from scratch. So on the data capture side, we have drones, lasers, measure oil drilling sensors. All these things already exist to capture that kind of current state of where things are today. I mean, you can include core drilling and assay sampling in here, as well as the technology that already exists in order to get the data on what you're working with in terms of the rock and the 3D model. Then in terms of the design, how do we design the blast? That's being done digitally almost everywhere now. So you've got digital versions of blast designs and digital QA/QC, which by that I mean, how deep was this hole actually drilled? Where was this hole actually drilled compared to the design? How much explosives were actually put in that hole? So that's there. Belt weight sensors, plant power draw. So then being able to measure those kind of output parameters. So the things that you want to optimize, the things that that really make you that money, that's all there. Those sensors exist. So on the data capture side, everything's there. On the data management analytics side, everything we talked about on the slide earlier is relevant. So the cloud data management that exists, it's easy to get all of this data into one place. Optimizers that can take this data and then tell you what the best adjustment to your blast design is, those exist. Those are used across lots of different industries, and there are off-the-shelf optimizers like your Garobi and things like this that just you can apply to multiple different situations. You can easily apply them to portfolio optimization in a hedge fund. You can apply them to drilling and blasting optimization here. So you don't have to build an optimizer from scratch. Photogrammetry, in order to kind of pass some of this data that you're getting from drones, AI models for passing some of that visual data from the drones to work out, what the rock structure is you're working with. That already exists. Rock hardness algorithms to pass the measure while drilling data and turn that into something useful. That exists, and fragmentation measurement using AI also exists. And a few of these things are things that Strayos does on that visual AI side. But yeah, a lot of that stuff that's there, ready to use. So basically getting the data, using the data, finding out what the best adjustments are for your pattern in order to optimize the output. You can do that using off-the-shelf modules that exist, modules of technology. And then finally, in physical implementation, you've got autonomous drilling is there now, a variable density and energy loading. Both Orica and Dyno are now playing in this space. Dyno with Delta E, Orica has 4D now. Is there variable density, variable energy product, so you can match the explosives that you're loading in the hole to the specifically to the rock hardness at different depth intervals through the hole. So you can use this to go even one level deeper with your optimization. And then connecting the outputs of your drilling design to the truck control system, also something that that exists, that OEMs are both providing, are all providing. So there are definitely ways that exist out there to be able to customize drilling and blasting, to optimize fragmentation without having to build anything from scratch. So now we looked at the modules and said, all right, we can do it. The next question is, we know we can do the whole, the grand plan of putting everything together, but where do we start? And the next thing that we might look at is, all right, well, what's the minimum amount of data that we need to do one of these to begin with? So here I've just kind of highlighted on this chart of all the different types of data, which ones we're going to need for our MVP. So you can start this with just a simple design data and crusher throughput data optimization model, essentially. Just get the design data, get the throughput data, connect it together, and then have it feeding into a continuous learning AI model, even just regression model to begin with, if you like, on the that lives somewhere in the cloud, so that it's proved that it can actually work. But yeah, this is only the MVP, just to prove it. What you then need to do is work out how to get that built into the workflows of the users, of the actual drill and blast engineers, of the drillers and the blast crew on site. And this is a key thing. This is what people usually fail at. So a lot of people get to this stage. Man, every time I change slides, a lot of people get to this stage and they do a one-off project and they say, yeah, this is our new drilling and blasting design handbook, guide, whatever you want to call it. Say we've done an analysis, and now this is how we're going to blast for the next year, for the next maybe 20 years. Embedding this technology into the workflows is the way to keep the models updating continually and keep people happy using the technology. Otherwise, you've done a study rather than embedding a technology. So embedding a technology means looking at who are the people involved. In the data capture side, we've got maybe the surveyors on site, maybe it's a contract surveyor, drilling and blasting contractor, could be the engineer going out and doing some of the data collection. Also people in the plant, should have put them up here as well, for data collection on the plant side, on the mill side. Then you've got data analysis. You've got your engineers maybe doing that. Maybe it's a BI person. Maybe it's someone who's the performance improvement level. Design of the actual blasting engineer, or maybe drill and blast superintendent, something like that. Then you've got the people in the field actually putting this in the ground. So the way that you can think about integrating this into their workflows is looking at what they do today. So maybe the surveyor is already flying a drone. So how can we just leverage that existing drone flight to create the 3D model? If the driller is already is out there drilling holes, if we put measure while drilling system on the drill, that can integrate into his workflow seamlessly. So he doesn't actually have to go and do any of the data collection themselves. They can just have that data transmitted wirelessly straight back from the drill. And then the plant, you can get sensors that are just continuously running that feed straight back into cloud systems. So how can we do that rather than have someone have to create a spreadsheet and then hand it to someone else, who then hands it to someone else? So that's where things tend to fall over, is once you kind of force people to start pulling data manually and then uploading it into other platforms. On the analysis side, it's really about putting everything in the cloud so that everything works continuously and everything's stored in one place. And it's also about having reporting that comes off that, use automated dashboards so that you can always see what the latest updates are. On the design side, this is a really big one as well. It's all well and good to have the optimization happening and to have it happening continuously, but the delivery of the results and the recommendations out of the back of that has to come where and when it's needed. So drill and blast engineer on site is potentially given a DXF boundary and said, hey, here's the next block to blast, create the drill, create the drill pattern. That's the point where they need the recommendation. It needs to fit into that workflow of them being given a boundary and them using a certain piece of software, whatever that is, to create the design. So an example of where that doesn't work is if they were just told by the system, use a 3-row pattern in a 5, or let's say like a 15 by 20 feet or 15 by 18 feet burden and spacing, and that pattern, those pattern dimensions don't fit the block that they've been given. Instantly, that means that the output of that model is kind of useless. So it needs to be tailored to their specific workflow. And then finally, getting it actually done in the field. That's where having that smart drill where you can have the actual hole positions wirelessly sent to the drill makes that seamless in the driller's workflow. and having the loading design for blasting synced seamlessly to the truck, so that when they get out there, they can just start loading based on what the truck is telling them to do based on the GPS location, so that there's no additional step required from the people in the field. So this is where this is really the key thing to try and get right when it comes to embedding new technology. And I'd encourage everyone to take this approach of looking at the stakeholders, going and looking at what their current workflows are and where they need to use the information that comes out of this. The benefits tend to be in the range of that, 5 to 10% total cost and throughput for fragmentation optimization. It's massive across the site. You can, as we said before, address those huge value pools, uplifting crusher throughput, uplifting dig rates. You can decrease your drill and blast costs. You can remove a secondary breakage machine, rock breaker, and decrease mill consumables. Energy has benefits for carbon emissions if you've reduced the amount of electricity you're using on site as well, which is another huge thing to consider. And beyond that, beyond just the cost, the value-based benefits, the same models, once you have them set up, can help prevent other things. So once you've already taken a 3D model of the pit, you can then start to look at slope failures. You can start to do road inspections. You've taken someone out of an unsafe location because they didn't have to walk on that bench to survey it. You're then able to manage vegetation, biodiversity, carbon emissions that we talked about, and also a whole host of other things relating to blasting, like reducing vibration, air blast, fume, etc. And definitely not least preventing fly rock, preventing damage to sensitive sites, and creating new jobs in the community, new high skill jobs for people in mining communities. So that's it. That's the happy ending, really, to kind of bring that to life. I hope this has been useful, and that there's a few things that that you can take away and apply when you're on mine sites and when you are involved in digitization projects. So thanks for listening.
Thank you, Brad, for your presentation. Hopefully you can hear us, but we're clapping.
Yep,
we're on my laptop mic, unfortunately. We do have a couple minutes for questions. Are there any questions from people in the audience with us here? While they're thinking, I was wondering what the industry's response to digitization has been regarding your experience. Like, how willing are people to adopt new technologies in this area, specifically from what you've seen?
Yeah, absolutely. So I've seen a lot of variation, I'd say. You've definitely got leaders and you've got laggards in terms of that kind of cultural openness to adoption. Unsurprisingly, tends to be like younger people tend to be more willing to adopt, more keen to bring in new technologies. But I guess that's at the field level. What I've seen is that it's definitely not a hard and fast rule, though, that people are across the board keen to adopt new technologies as long as you involve them in the kind of co-development of those technologies. And at the corporate level, so that was kind of at the field level. At the corporate level, there's without a doubt everyone now is focused on this as a key kind of enabler for their success in the future.
Thank you. We actually have a couple questions from the audience. I'm going to go in order. What measures are put in place to prevent cyber attacks / data protection? This question's from Michael Haslam.
Yeah, sure. So mining is an industry where a lot of the data is, a lot of companies still like to keep the data on premise. So I've been talking about cloud, and I guess I've been talking about, more Azure, AWS, as you know, these are very secure cloud services that are used everywhere, that have the same security as any other system. If someone hacks Amazon, then we're all kind of screwed. So so that's the best defense if you're in that public cloud, is to have it on one of the industry leading providers, so you can leverage their data protection, their cybersecurity. But a lot of mines will still have servers on premise, and then want to keep their data in physical servers on the mine, so that they can prevent against that as well. So I don't know if that's the way that it's going to continue moving forwards. Like if you look at other industries, everyone's kind of takes their time to move away from the on-premise data storage unless there's a really good reason. I could see mining kind of moving away from that, gradually becoming more okay with using the cloud services. But yeah, that's another way that mines do it now.
Another question from Gordon Fellows. Acceptance and change management remains an issue for implementation, even when operators and supervisors have been members of the design and development teams. Any suggestions regarding change management?
Yeah, so change management is like 80% of the work that you have to do implementing anything new. Like broadly, there's a few, other than just involving people in the development, there's a few things to get right there. So it's having the dedicated resources to look after that change management, I think is number one. You need people who have done that job but are not still distracted by their day-to-day jobs, because change management, if you try and get someone to do it who is still in another role, the change management will always take lower priority on their list, and things just won't get done. You need people to be dedicated to this. You also need to establish some champions at all levels of the business, who are going to push this. So having, even if there's kind of a manager who's running this, who's responsible for delivering the initiative, and they've involved a few people from the team, you need people from outside the team who are excited every time you go and launch it somewhere different to be involved in almost just being cheerleaders for it and getting everyone excited. So picking those people very intentionally based on who has the most kind of social influence within organizations is something that's often key to rolling things out, to implementing. But yeah, there's also there's a lot more in terms of change management that we could go into. It could take up an entire course.
It almost seems like a psychological issue more than a mining explicitly one. Yes, we have a question from our audience. Hopefully we'll be able to.
Brad, I enjoyed your presentation. I have one question. You had a slide on what type of returns, financial returns one would get from this implementation, but you didn't talk about the investment side. So when we combine,
what side? Sorry, it cut out for a second.
When we combine the investment with the return, what type of ROI do you see?
Yeah, gotcha. So how much does it actually cost to set up something like this? So in the case of fragmentation optimization, I guess I didn't include it because it's generally quite negligible compared to the overall size of the prize. In order to, let me get back to the slides. Like setting up some of these systems, so like drones cost a few $1,000s. Getting that, even a fully outsourced drone survey is in the tens of thousands of dollars per year. Kitting out drills with measure while drilling sensors can be a bit more expensive, in the few $100,000 range. Putting sensors all over your crusher, grinding mills, again in that kind of tens of thousands range, and then actually setting up the optimization software side of things. So, I mean, that's something that Strayos offers, and that's still in that tens of thousands of dollars range. It's very low compared to the output of the entire system, where if you've got all these things together, maybe the total is in that hundreds of thousands range, mostly driven by the hardware changes, which are somewhat optional. And if you're looking at things like 5 to 10% of throughput, for example, you're pretty much always talking in millions. So if you then think about those two things together, you've at least got that 10x or more ROI.
Great, thank you.
Thank you for your question.
No, it's a good question. I see another one come through in the chat too here.
If you'd like to read it, just so it's
Sure.
documented.
In your experience, how many times in a year or a month to analyze new data again to update predictive models? Is it necessary for a permanent engineer supervising only and specific minor operation? So this is where in the MVP, you'd have a standalone model that just, you do it once to prove that you can do it, that you can get the data, and that you can make a model out of it. But in the operational world, when you build the system that's going to work continuously, that's where you definitely don't want to be building a system that requires an entire new person to be running that system. So definitely don't want to be building anything that creates so much new work that you need a new engineer, which is why you have to try and embed it into existing workflows. So having a model that having everything be integrated. Remember, we were talking about getting lots of modules that are integrated together. Having a model that's integrated so that you can seamlessly and continuously capture data from those sensors, from your drill and blast design. So like every time you do a drill and blast design, it automatically updates your optimization model inputs. Having that stuff just be seamless means that the model can be continuously updating. So it's not like every week or something you go and update the model. The model is just being fed this data through all these different integrated sources, and it's also outputting recommendations and predictions without any additional work being done. It just pushes them in when you're doing the blast design, for example.
Thank you, Brad. If there are no more questions, I wanted to say thank you again for taking the time to come talk to us. Thank you, everyone in the audience, for watching, both in the classroom and online. As a reminder, this was recorded, so it'll be available on YouTube on the Mining Engineering Seminar page. And once again, just thank you to everybody, and we'll see you next week. Thanks again, Brad.
Yeah, thanks, guys. And feel free to reach out if anyone has any more questions or follow-ups or anything like that. Yeah, I think you have my email from the, is it on the flyer? Either way, brad.gingell@strayos.com.
Perfect. Thank you very much. I'm going to close it out.